In coming illustration, we are going to take the same category of the concepts. That means through coming illustration, we will cover number 1, analyzing object in the combined rotation and translation. Number 2, identifying the location of the instantaneous axis of rotation. Number 3, how to write the constraint equation in the rotational dynamics. And number 4 and last point, but very important point, is the application of the torque equation. So let us move to the illustration part. The illustration is in the given figure. A and B are two identical blocks. You can observe here in this figure, this block A and this block B both are having the same mass. Block A is placed on the smooth horizontal surface. That means there is no friction between block A and this surface. Okay. And C is a circular disc. This is a circular disc of equal mass small m. That means this disc is also having the mass small m. Pulley is massless, this pulley is massless and frictionless, and thread is inextensible. Neglecting the friction, calculate the acceleration of the block A and B. We need to neglect the friction here and here also, and mass of this pulley is given. That means we need to consider the moment of inertia of this pulley and rotation of this pulley. That means friction will be present here, but there is no friction here. If there is no friction in this pulley and this pulley is small, that means tension on this thread and this part of the thread will be equal, but tension in this part and this part will be different. Okay. Let us do the first location of the instantaneous axis of rotation. First we are going to analyze location of the instantaneous center of rotation. So let us do one thing. Let us place the diagram here. You can observe here this part of the string. You can observe this point is a fixed point. You can follow the location of the tip of my pen. You can observe here this point is not moving. That means velocity of this point is 0. Also acceleration of this point is 0. This string is directly connecting this point. That is the point of the disc. Say this point is A point. That means A point is directly connected with the top of the roof, which is not moving. That means this point is also not moving, having the 0 velocity and 0 acceleration. That means this is the instantaneous center of rotation. Okay. This is the instantaneous center of rotation. Now let us observe the rotation sense of this pulley. If you take the torque about this point, you can observe here this tension, or you can say the weight of this block will try to rotate this pulley, or you can say this disc, in the clockwise sense. That means the pulley will rotate, or you can say disc will rotate in the clockwise sense like this. Let the angular acceleration of this disc is alpha, right? If this is alpha, that means this center is at a distance small r from A. The linear acceleration, you can say tangential acceleration of point C, will be in the downward direction, will have the magnitude equal to r alpha, and this will also r alpha. Why? Because this point is directly connected with the block. You can say the acceleration of the block will also r alpha. Now consider this point. Say this point is a point B. The distance of point B from A is 2r, and rotation sense is again, it is clockwise, distance is 2r, angular acceleration is alpha. That means the tangential acceleration of B point will be the downward direction. That will be equal to 2r multiplied by alpha, or you can write here 2r alpha. Now you can observe here, this string is directly connecting, it is passing through this pulley and directly connecting this block. This block is placed on the table, smooth table. That means the acceleration of this point should also be 2r alpha, but in the leftward direction. So these are the accelerations of the blocks and pulley. We got the constraint relation here. Now we can draw the free body diagram. Let us first take block A. Block A is having the three forces, that is the weight, downward direction, mg, normal reaction rotable on the block will act in the upward direction, say N, and tension force will act in the leftward direction, because tension force, you know, it is a pulling force, this is a pushing force toward, and this is away, this is T1, right. This is the free body diagram of the block A. Now let us consider the free body diagram of the block B. Block B is having the two forces, that is the weight and tensor force. So this is the free body diagram of the block B, and we know the acceleration of the block B is R alpha, that is in the downward direction. Now consider the free body diagram of this pulley. You can observe here the pulley is having the four forces: tension here 1, tension here 2, tension here 3, and weight. So let us make the free body diagram of this, right. Weight will act in the downward direction, that is mg, because mass of this disc is same as the mass of this block and this block also. This is mg, and you can observe here this is tension, because this string will have the tension T1. This part of the string will have the tension T1, because this pulley is a smooth and light pulley. That means tension on this part and this part will be the same. This is T1. And tension here we have considered T2. That means tension here should also be T2. And let us consider tension on this part of the string is T, like this. So this is the free body diagram of the pulley. Now let us write the equation of the motion. Let us start from block A. Block A is, you know, it is accelerating in the leftward direction. So here we can write here T1 equal to mass multiplied by acceleration. This is equation number 1. Now let us consider block B. Block B is moving in the downward direction. That means net force on the block B should also be in the downward direction. So net force on the block B should be equal to mg minus T2, that should be equal to mass multiplied by acceleration, that is R alpha. So this is the equation of motion for block B. Now let us write the equation of motion of pulley. Let us first write this equation as equation number 2, right. This equation number 2, let us rearrange the equation, that is T2 equal to mg minus m multiplication R alpha. Now we are returning to the pulley part. You can observe here pulley is rotating. The motion of the pulley is rotation and translation. So let us write the torque equation, okay. And as we discussed, we can apply the torque equation about only 2 points. One is the centroid of the object, second is the fixed point or instantaneous center of rotation. So A is the instantaneous center of rotation. That means we can apply the torque equation for the pulley, or you can say disc, about A. So let us write the torque equation about A. You know, this is having the acceleration alpha. So let us write the torque equation about A. The sense of the rotation you can observe here, this is the clockwise. So let us take clockwise direction as positive for calculating the torque equation. So we can write here this mg and T2 will provide the clockwise torque, and distance is capital R. So torque of mg plus T2 is R multiplication mg plus T2, and this torque will be in the anti-clockwise sense. So this is minus T1 multiplied by 2R. This is 2R. That is equal to Ia multiplied by alpha. This is the torque equation. Let us again put the value of Ia. I is the moment of inertia of this disc about A. This disc is a circular, mr square divided by 2 plus mr square, that is 3 by 2 mr square. So Ia equal to 3 by 2 mr square, we can substitute here, right. And here we can cancel out r. This will cancel out, okay. So the equation will be finally mg plus T2 minus 2 T1. This is equal to 3 by 2 mr square. This equation number 3. Let us place 3 equations, equation number 1, equation number 2 and equation number 3 to the next page. This equation number 1, equation number 2 and equation number 3. Now let us solve these equations. We can do one thing, we can substitute the value of T1 and T2 in this equation, right, like this. Let us substitute these value, okay. And you can observe here this m, m, m and m also will get cancelled. So, the final equation after solving will be this one, and from this we can find the value of R alpha. If we put this value 5R to the right side, this value will become 13 divided by 2 R alpha equal to 2G. That means R alpha equal to 4G divided by 13. Okay. For R alpha is nothing but acceleration of block B. That means acceleration of B equal to 4G divided by 13. Right. This is the acceleration of block B, and we know acceleration of A is 2 R alpha. So, acceleration of A is equal to 2 multiplication of this value, that is equal to 8G divided by 13. So, this is the acceleration of block A. Okay. In the coming illustration, we are again going to repeat the same concept for strengthening the topic, that is analysis of the combined rotation and translation. Second is the identifying the location of the instantaneous center of rotation. Third is the how to write the constraint equation, the rotational dynamics, and fourth is the application of the torque equation. Let us take the same type of the problem again with slight difference. In this diagram, you can observe this is a smooth horizontal surface, and you can observe here this block is placed on the surface and it can move without friction on this smooth horizontal surface. The mass of this block is a small m, okay, and this is a step pulley of radius A and B. Inner radius is A, outer radius is B, and moment of inertia of this pulley is I naught and mass of this pulley is capital M. Okay. The mass of the block placed on the smooth horizontal surface, yes, we have discussed this is small m, and this pulley is massless and frictionless. Again, we need not to consider the rotation of this pulley. That means the tension on this part and this part will be same, but tension on this part of the string and this part of the string will be different, because moment of inertia, mass and size is given. That means this pulley will rotate. And in this question, we need to calculate the acceleration of the block, acceleration of this block. Okay. First of all, we are going to repeat the same type of the exercise, that is identifying the location of the instantaneous center of rotation. For this, let us draw the diagram again. This is the diagram. Okay. You can observe here this string is finally connected with the roof, and this is a fixed point having the 0 velocity and 0 acceleration. And this string is connecting this point of the pulley directly. That means the acceleration of this point should be 0 and velocity of this point is also 0. That means this point is momentary at rest. This will be the instantaneous center of rotation. That means this overall pulley, or you can say this disc, will rotate about this point. Now, sense of the rotation, this will move in the downward direction. That means the rotation sense of this pulley will be counterclockwise like this. And let us consider the acceleration, angular acceleration of this pulley is alpha. You can observe here the center of this pulley is at a distance small b. That means the acceleration, that is the tangential acceleration for this rotation, and you can say the acceleration of the center of this pulley will be b multiplied by alpha. This is b multiplied by alpha, right? This is the acceleration of the center of the pulley. Similarly, you can say this point, say this point is b point. This b point is at a distance from a point is a plus b. This is a and this is b. So, the radius of rotation will be equal to a plus b. Angular acceleration is alpha. That means acceleration of this point b will be in the downward direction and magnitude equal to a plus b multiplied by alpha. This is the acceleration of point b. Now, you can observe here this string is directly connecting to this point of the block, right? And this will move in the rightward direction. That means the acceleration, magnitude of acceleration of this point B will be the same as the magnitude of acceleration of this block, that is a plus b multiplied by alpha. These are the constant relation. Okay. Now let us move to the free body diagram. First we consider the free body diagram of the block. Block will have the three forces, that is the weight mg downward direction, normal reaction applied by a table on the block in the upward direction. Normal reaction is a pushing force, that's why it is acting toward the object. Tension force will be in the rightward direction. Tension force is a pulling force. So let us consider the tension in this string or this part of the string as T. So this is the free body diagram of the block. Now we can write the equation of motion. This object cannot move in the vertical direction, that means N equal to mg. These forces will be balanced. This is the unbalanced force, that means we can apply the Newton's second law of motion for writing the equation of motion of this block. So let us write the equation of motion. We can write T equal to A plus B multiplied by alpha multiplied by m, right? Or you can say T equal to m multiplied by A plus B multiplied by alpha. This equation number 1. Now move to this pulley. This is the movable pulley, and let us write the torque equation first. And here we are going to write the torque equation about the instantaneous center of rotation. Okay, so, let us do one thing. Let us make this pulley separately like this. Okay, now consider how many forces are acting on the pulley. Tension force and tension force, two forces here and one force here, that means three forces. That the weight mg is acting, capital mg is acting in the vertically downward direction, and this tension, this part of the string is having tension T. T will act in the upward direction, and tension in this part of the string will be different. So write here T dash. This is T and this is T dash. This is the free body diagram. And you know the acceleration of the center of the pulley is B alpha. So this is B alpha in the downward direction. Let us write the torque equation about the instantaneous center of rotation, that is about A. Let us assume we have taken the acceleration, angular acceleration alpha. So this is alpha. So let us write the torque equation. We can observe here this rotation is the anti-clockwise sense. So let us take anti-clockwise direction as positive. That means the torque about A of force mg is mg multiplied by B. Torque of T dash will be 0 and torque of capital T will be equal to T multiplication A plus B, right? And here you know we have taken anti-clockwise sense as positive, that means clockwise will be negative. That means net torque about A should be equal to mg multiplied by B, this is B, minus T multiplication A plus B, that is equal to IA multiplied by alpha, right? IA is the moment of inertia about the instantaneous center of rotation, and we know the moment of inertia about the centroidal axis is I naught. That means we can apply the parallel axis theorem to calculate the moment of inertia about A. So we need to add I naught with the term mass multiplied by this separation square. So moment of inertia of this step pulley about A should be equal to I naught plus mb square. So let's write the value of IA. This is the value, equation number 2. Okay, let us write this equation number 1 and equation number 2 the next page. This equation number 1, this equation number 2. Okay, now we can do one thing. We can substitute the value of capital T from equation number 1 to equation number 2, right? So let us substitute the value of T in equation number 2. This equation will become like this. You can observe here we can find the value of alpha from this equation. We can rearrange this equation. We can take this term to the right side to get the value of alpha. That means alpha is equal to, this will be mgb divided by this plus this term, right? This I naught plus mb square plus m a plus b whole square. So alpha will be this, right? We got the value of alpha. Now we need to calculate the acceleration of this block. This is equal to A plus B multiplication alpha. So acceleration of the block, this will be equal to A plus B multiplication alpha. and we have calculated the value of alpha. We can substitute here, and this is the final acceleration, that is capital mgb a plus b overall divided by I naught plus capital MB square plus m a plus b whole square. Okay. Dear students,